The process we're going to do today is a little bit tedious, for a heads up. We're going to take all of our stuff that we've looked at already for graphing and looking at rational functions and put them all together. Now, first, there are 4 things you want to remember for this always. 4 things, and these are the things we've already talked about. Asymptotes. For asymptotes, please write down that you have 3 types. You have your vertical, which was the first ones we looked at, where the vertical and the holes, those 2 placed together. And then we also have horizontal and slant. We looked at those together also. Remember, the horizontal and the slant asymptotes really have to do with end behavior. This is really end behavior always. The vertical asymptote comes about from discontinuities. Okay, again, so we have 3 types of asymptotes: vertical, horizontal, and slant. The vertical one came from the denominator being 0. That's where that came from the discontinuity. The horizontal and the slant, those had to do with what? The degrees of the numerator and denominator. Okay, these are the kind of notes you should have written down next to these words so you understand where you're going back to. The horizontal and slant, those came from looking at the degrees. That was the second assessment today on concept 44. The vertical one, that was from a while ago we talked about still. That's where you test the denominator and set it equal to 0. And you look for any holes instead. When did we have a hole in the graph? What caused having a hole? Juliet?
When you factor and you have the top and the bottom.
Very good. Remember, the hole occurred from the same factor in the top and bottom. So let's write that one down now. Same factor in the numerator and the denominator. Again, why did that actually occur is because when you plug it back in, you get 0 over 0. That's where we showed it from. But the trick, or the easier way to remember, is just to look for the same factor. With the same factor, you're going to get 0 over 0, which is our indeterminate answer. The third part, that's the part we did on Tuesday, our intercepts. For our intercepts, remember several things. First, the y-intercept is the easier version, right? You just set x equal to 0. So for the y-intercept, let's just say what we always say, set x equal to 0. Remember that the y-intercept could be one of 2 things. Either it could be a number, or it could be does not exist. Because remember, if you have all x's in the denominator, and you set it equal to 0, the denominator becomes 0. So you get some number over 0. So either you can have a numerical value like 0, some number, that's what it'll look like, or the y-intercept sometimes does not exist. Those are my 2 options we talked about. Remember, depending on the type of problem, if the denominator, every term in the denominator has x in it, they're all going to go to 0, then you set x equal to 0. So you end up getting a number over 0, which does not exist. Finally, the x-intercept, yes, we do set y equal to 0, as always, but what was the conclusion we made? What's the only part that really matters for the x-intercept? The numerator. Again, the numerator, you find the roots for, really. You find the roots for the numerator. Guys, this is all review, and I apologize if I'm going fast, but this should be second nature now. If it's not, that means you need to be more studying on your own. I'm not going to slow down our review stuff. When we do the problems, we'll go a little slowly, but all this stuff I'm writing here is all review. The numerator's roots are what matter really when you find the x-intercepts. The numerator's roots. What caused the problem? When would it not be a root? For example, if my numerator, if I had a problem like this where my numerator factored into x plus 2, x minus 3, and the denominator was, let's say, 2 quantity x plus 2. What would the problem be there with the x-intercepts, Anna? Good. Remember, this one does not cause an x-intercept because it's a hole. So the x-intercepts come from the numerator's roots, but you always have to check for holes. Okay, again, for this kind of a problem here, if the numerator and denominator have the same factor, you're going to have a hole there. I'm not going to slow down at all if you ask me again, because you're now talking instead of listening. The numerator's roots are what matters. Check for a hole. Those 2 things. Yes?
What's P and E again?
What's P and E? D and E. D and E. Sorry, D and E does not exist. The last part is not needed always. It says if necessary for a reason. If necessary just means, as it says, if it's necessary. If you have enough points, you can see the curve, don't worry. But there's certain times you're going to notice that the y-intercept, the x-intercept, and these values don't give me enough information. So I do want to plot a few extra points. So the last part is like we've done before. Just plot some points. And we'll go through how to do that as well. Let's look at a first example to go through all these. Now, I wrote down a hip. Again, it doesn't matter. Do whatever you need to do to memorize it. But I saw A, H, I, P. That's where that came from. So if you want to make an acronym, switch these around. But I don't know if there's any other one that'll work. Like P-A-I-H doesn't work. What?
PIHA.
PIHA, P-I-H-A. I mean, it's not a word, but anyway, make an acronym for these to help you. First one. First one. Let's start with our asymptotes. Before we do any of these kinds of problems, people, before we do any of them, the easiest thing to always do is to start by factoring. Okay, start by factoring. What does this factor into? Good. A lot of you notice right away this is an example of dots. Difference of two squares, dots, dots, dots. Now, once I have it factored, I can clearly see already in my denominator what will cause discontinuities. What will cause a discontinuity here? Negative 1. Negative 1. Be careful again, not 1. 1 plus 1 is 2. That does nothing for me. What caused a discontinuity here, though? That's positive 1. Again, this one, x cannot equal negative 1. That's my first discontinuity. And here, x cannot equal positive 1. Now, once I know their discontinuities, I have to check to see if they're holes. Do these factors repeat themselves?
No.
They don't. So these are both vertical asymptotes. If they had repeated themselves, they'd become holes, and we'll talk about that in the next example. Again, if they had repeated themselves, they would be a hole. Actually, we won't get to a hole until the third example or fourth. If you saw x plus 1 in the denominator and x plus 1 in the numerator, those cancel. That's what indicates the hole. Okay, a common factor in the numerator and the denominator. So that's my vertical asymptote. Now, for end behavior, I want to look at this function here. The degree of the numerator is what?
2.
Numerator. Just a 1. There's a 1 here, really. The denominator, that's our 2. Again, the degree is the highest exponent. If the degree of the numerator is less than the denominator, what is your asymptote here? What is it? 0. Very good. The asymptote is a horizontal asymptote, and it's y equals 0. Derek, either you memorized it or you plugged in infinity. Which one was it this time? You just remembered it. Okay, I recommend that again. Whenever the degree of the numerator is less than the degree of the denominator, you always have a horizontal asymptote at y equals 0. Okay, that always happens. So in this case, that's our horizontal. So we've got two vertical asymptotes already, and we've got a horizontal asymptote. So already I've got a lot going on with this graph. We've done our asymptotes already. Okay. H, what did H stand for? From a hip, I said before?
Holes.
Holes. Did we have any holes?
No.
No. We didn't have any holes. The third part was the x and y intercepts. Let's do it. For this kind of a problem for the x and y intercepts, I would recommend using the factored form for the x-intercept, but for the y-intercept, just use this form, because it's a lot easier. For the y-intercept, take a look at the y-intercept. What do I have to always do? Well, if I set x equal to 0, what does the numerator become, guys? 0 over some number, right? Isn't that a 1 there? Or a negative 1? But 0 over anything is still 0. So the y-intercept is just 0, comma 0.
So it's like the numerator was like 2x squared and the denominator was like x. So that means that the horizontal asymptote will be 0.
No, you're confusing yourself. No, that would be a slant asymptote. Look at your nose, please. Okay, again, guys, plug a 0 in here. You get 0 over 0 minus 1, which is 0 over negative 1. 0 over anything is 0. That's where the y-intercept comes from. That's why the y-intercept is 0 here. Had it been 1 over 0, it would be does not exist for the y-intercept. That's when it does not exist.
If you ever get 0 over 0, is that 1?
No, it's called indeterminate. That's where the hole comes from. Remember the idea of a hole in the graph? That's where you get that. Whenever you get 0 over 0, you write down either undefined or indeterminate, especially for this example for y-intercept here. But again, you're going to notice if you ever get anything over 0, your y-intercept doesn't exist because you'll have a vertical asymptote along the y-axis, and your curve will just go like that up to the y-axis. It won't ever cross because of the vertical asymptote there. So for the x-intercept, we simply said y equal to 0. Now, what did we say was the important part for the x-intercept?
The numerator.
Only the numerator. Good. We factor, yes, the factor form. But the factor form doesn't mean any different because it's only the numerator that matters.
So basically just 2x.
So we end up getting, just 0 equals 2x from the numerator. So what's the x-intercept actually? It's also 0. Solve for x, guys. Divide by 2 on both sides here. Divide by 2, divide by 2. You get 0. So this makes sense to me, though. The x-intercept turns out to be 0 because take a look. The y-intercept is 0. If the y-intercept is 0, well, the x-intercept is also 0 in this case. Because that's the origin, isn't it? And think about it logically. Draw a graph in your mind. If the y-intercept was 0, it's right here, isn't it? Well, isn't that also the x-intercept now? The origin is an intercept for both, actually. So when you get an origin as an intercept for the y, it's also going to automatically appear as the x. Okay? Again, how do we do this? We're really setting the numerator equal to 0. That's the important part there. We're really setting the numerator equal to 0. Okay? Why did we do that? We did it last class. If you want to see yourself, try it yourself. Plug a 0 in right here. Multiply both sides by this by bringing it up. It still becomes 0. You're left with 0 equals to 2x there. With all this information, we're going to sketch our graph. So let's start. A vertical asymptote at 1 on each side. Put a vertical asymptote here on each side. You guys have a graph on yours, make it easier. I've got a horizontal asymptote at 0. That's this right here. So I've got two things to start. Again, the dashed blue vertical lines are my vertical asymptotes at -1 and at +1. My horizontal asymptote is y equals 0, which is really just the x-axis. That's that red line, that horizontal red line there I put across. Now, once I've graphed the asymptotes, I want to graph any holes. But I don't have any holes in the graph, so I don't have to worry about it. After holes, I want to graph the intercepts. Well, this is my only intercept, the origin right here. So for this kind of a graph, you're going to need other points. You're most definitely going to need other points. That fourth step. Remember, the first step was asymptotes. The second was holes. The third was intercepts. And the fourth was any points needed. You clearly need points because looking at this, I have no idea what's going on here. So here's my recommendation for you. If you do it this way, it makes it really easy. Look at your vertical asymptote and pick some numbers near it. So the vertical asymptote here is 1, right? So when I make a table here to test a bunch of values, when I make a table here, I'm going to pick numbers like 2 and 3 and 4. And I'm going to pick numbers like -2, -3, -4. In here, though, you're going to have to use some decimals. I highly recommend you use your table function in your calculator. Do not do these by hand. Okay, there is so much room for error. Please, again. So this is x equals 1. This was x equals -1 over here. So I'm going to choose 2, 3, 4. Because those are all points to the right of here. I'm going to choose -2, -3, -4. Okay, as my first, let's say, 6 points. Then I need to choose some points in here. Well, this goes from -1 to 1. So you might want to choose like a half or a quarter or 3/4, stuff like that. So my other points I would choose, I'm going to continue the table over here. Well, actually, let me just continue looking down. John, say again? Yes. So continuing this table, I would choose points in the middle here. So a point like 0.5 and 0.75, 0.5 and 0.75. and then maybe the negative side as well. So a lot of graphing when you graph rational functions comes from a table of points, which is very different from the past. Think back to like quadratics and linear. I always try to teach you guys that you don't need tables of points, because a lot of the time you can describe the shape of the graph by looking at its characteristics, by looking at A, B, C, all that stuff. But here, clearly we're going to need this table. It's not going to help me just to have the graph by itself. So at this point in time, all you want to do is go ahead and look, plug these into your table, and actually list the values, and then plot your points. Okay, did anybody get through some of these already? You should be trying this on your own, guys. If you can't do it here, you can't do it on your quiz. And I know all of you should have calculators by now, so I should see everyone trying this. Again, your rational function needs to be in parentheses, the numerator and denominator, or else it will not work. Again, it will not work if you don't have it in parentheses. Anybody got the first few at least? 1.3. And give me nearest 10th, please.
0.75. 0.5. Negative 1.3.
Talk to me after class. I'm sure it's symmetric, I think, here, right? Is that correct for the next one also? I think there's symmetry in this graph, if anybody noticed. Pretty sure these points will end up flipping flopping. Last few here?
Negative 1.3.
Yeah, don't even try it.
Negative 3.42.
It's 4.3.
Yo, can I do something wrong?
What?
No, I'm just crossing it off.
You didn't even try it about that.
You have two left. I have one left.
Last two, anybody?
We need to see
Do we just have opposites here, guys?
I'm -4.
Check your numbers, people. Again, you should have the same ones. If there's something that's not the same, raise your hand and ask, because you know what? Doesn't mean it's all right up there. I only ask one person for this. Daniel.
Put it aside.
Put this in the y equals. Second table, and then plot this twice in the table. Did you get what? The points around the vertical axis. Your vertical axis is going to be 1 to negative 1, right? So I take 2, 3, 4, negative 2, 3, 4. Besides that, equal your time.
Actually, I was actually finished at like 11. And then I remember like at 1 and I still have to do that finish on the night. I never got to do the rest of There was written stuff too. The rest. Yeah, Julia just told me.
You just said do chapters 4, 5, 6, 8.
Oh, it looked like 6 3 from the back? Gotcha. Okay.
Oh, that.
Yeah, negative 1.3, sorry. All right, so those are my points. Now, given these points, go ahead and graph them on your graph. And look at your graph on your calculator when you graph these, guys. Don't just use your paper. You have your calculator, check on there. So I'm going to start with the first, let's say, 6 points.
Do we have to write it out?
How else are you going to get it?
No, I mean like,
Can you just put them right on from the calculator? As long as you show me the point, I'm happy with that. But I don't want to just see, Julia, I don't want to see this. Like, You know, because that's, I think, the general shape of the graph, something like that, right?
Yeah, it's like
I don't just want to see that on your graph. I want to see the points and where it comes from. So if you show me the points, that's fine. You don't need to write the whole table out now, because it's on your calculator. So 2, 1 point. Now, the question becomes this, guys. I haven't labeled my y-axis yet on my graph. And look at these points. What's the smallest and biggest y value?
Oh, wait. Smallest Y value.
3.4, okay? 3.4. Again, 3.4 is the biggest, and negative 3.4 is the smallest. So along your y-axis, you don't really need to go anything beyond 4. So see how many tick marks you guys have? Go every 2 for 1. Every 2 boxes, make that 1 unit along the y-axis for you. Again, look at your graph on your paper. Utilize the full graph, please. So every 2 boxes on your paper should be 1 unit. So I'm just going to list 1, 2, 3, and then 4. Again, I'm only going to -1, -2, -3, and -4. You do not need to label all of them. Okay, as long as you label one of them, I know what the pattern is. It's got to be consistent, though. Now, if I'm going to graph these points, 2, 1.3. 2, 1.3 is right here. 3.75 is right here. 4.5 is right here. So I can see, please remember, guys, this is a God bless you, a vertical asymptote. A vertical asymptote is when the graph is going to get closer and closer to it. Julie, up here, please. The graph is going to get closer and closer. So this has got to curve upward. It's not going to just suddenly go like this. Watch. It can't just come back down, because that would cause another x-intercept there, wouldn't it? And we don't have an x-intercept there. So it's got to continue upward. Again, an asymptote, either it's going to get closer like this, or it's going to come down and get closer like that. But it can't come down, because that would cause another x-intercept. So I know that for this kind of a problem, those 3 points must continue upward. So these 3 points have to continue up like that. And this is a horizontal asymptote. It's my end behavior. So it's also going to ride along there. What do you think about down here from those points? It's going to curve down, the opposite. Look at your values, please. You're going to see that this is going to be -1.3, -0.75, and then this is -0.5. And this one has got to curve down. It can't curve back up because, again, I've got 3 points, and if those 3 points started to curve back up, you'd have another x-intercept. The middle part is the weird part if you look in your graph, and you'll notice that. If you guys want to zoom in, you might want to go from like 5 to 5 and 5 to 5, or -5 rather, okay, for your window settings on your graph, because I'm only going to 4 on the ends, and I'm only going to 4 on the y-axis. So when you're graphing this, graph on your calculator the same way you would graph on your paper. I got a lot of points to plug in here. So let's see. A half is -1.3 and -3.4. So a half is -1.3, and then 3/4 was -3.4. That's another point right there. On the other side, I have the opposite. I've got 1.3 positive and 3.4. So looking at these points here, I've got a point. Somehow I can do this maybe without typing. I've got, yeah, you can't. Look inside this box. You're going to see 5 or 4 black points here. These 4 that I'm pointing to right now. Those 4 points and the x-intercept in the middle, they all connect. What kind of a shape does that remind you of when you're looking at your calculator? Not a parabola, no. Cubic. Very good, Victoria. Cubic. Look at that middle section. It looks like a cubic function. It has that general shape, that general cubic shape to it. Okay, so go ahead, use your calculator and get an idea of what it looks like first, and then graph it. And you should see this. You should see that, yes, there are vertical asymptotes on both sides, and it has this like curve and maybe like an inflection point there in the middle. Okay? Are we clear on that? Yes.
Wait, how do you get that line between?
With the points and with your calculator, graph it together. Utilize your calculator to help you see the curvature. Again, utilize your calculator to help you see the curvature. But for here, you can use the calculator, but you should also know it's got to go up. Because if it came back down, it would have another x-intercept, which we don't have there. Same thing here. This has got to go down. Because if it went back up, the x-intercept would be thrown off. it's not coming back around. It's getting closer to the asymptote. See, like this gets closer. Yours, you came back around here. It's getting closer to the asymptote, closer to the asymptote. The asymptotes are where the graphs are always going toward, guys. This one's going up, this one's going down. This one's going down, this one's going up. Let's try a second one. First thing to start with, factor top and bottom. Numerator, what do I get?
X plus 3.
Can I factor the denominator?
No.
Yeah, no.
The only factor like is one. You can't really factor.
You can factor it to 1, but does that do anything?
No.
Again, the denominator here cannot be factored. It's not difference of two squares. There's no GCF. You can't, factor like a trinomial. Again, the denominator, leave it alone, please. So, with that said, let's start with our asymptotes. So first thing we have to look at is say, what would make the denominator equal to 0? Well, since it can't be factored, it's not as obvious now, right? Again, look at the denominator. It's not obvious what would make that 0. So let's take the denominator and just set it equal to 0. So to find our vertical asymptotes, again, remember, we look to see when the denominator equals 0. But it's not obvious. So let's just set it equal to 0 and see what we get. What do I do to solve for x here? Step me through the process.
You move 1 over.
Good.
And then divide by 2.
Divide by 2.
And then square root of.
Okay, when I take a square root of a negative, what's going to happen? What do you get? Imaginary. You're thinking of squaring. Be careful. When I take a square root of a negative, I get an imaginary answer, don't I?
Yeah.
So in this case, if I get x equals, and you get plus or minus the square root of negative 1/2, that's not going to help me, because those are imaginary asymptotes. They don't exist. So in this case, there are none. And I want you to see that in the second problem right away. There do not have to be vertical asymptotes. They don't have to appear. So please, don't assume that they appear just because it looks like it's a rational function. So there's no vertical asymptotes, and also, there's no holes either, because you don't see a repeating factor, right? So also, let's write down, for holes, that there are none. Next, look at the degrees of the numerator and denominator. The degrees are equal, greater than, or less than? Equal. Very good, guys. Right away. You see the 2 here and the 2 here. The degrees are equal. When the degrees are equal, what kind of a horizontal asymptote do I have?
Don't want to say slant.
It's not slant. Slant's on the top, greater than the bottom. You have to use division.
No.
This is the type of board.
Is that just on the horizon?
Where's it?
You said 5, 6, 7, 8.
It's always the leading coefficient of the numerator over the leading coefficient of the
One
denominator.
over 2, so.
Okay?
Yeah, you go to
1/2. Again, my horizontal asymptote, whenever the degrees are equivalent, is the leading coefficient of the numerator, which happens to be 1, over the leading coefficient of the denominator, which happens to be 2. Well, y equals 1/2, a lot of people think that that's a slope because they see the 1/2. If you need to, write it like this. Write it as 0.5. So you know that when you graph later on over here, if your 1 is here, you don't have to draw the graph right now. But the horizontal asymptote will look like this later. Okay, keep that in your mind. It's not a slope. It's a line at 0.5. That's what 0.5 really is. But we'll get to the graph in a minute. Before we do that, though, we've got right now we've got our asymptotes done. No vertical, 1 horizontal, no slant because the top is not bigger than the bottom. For the holes, we have none. That's A and H. I is intercepts. Take a look at your numerator. What are your x-intercepts going to be automatically by looking at the numerator? How do I find the x-intercepts? X, X, X.
0.
Set y to 0, but what do I really care about again? Only the numerator. What would make the numerator 0? What is it, John? So my x-intercepts in this case, my x-intercepts are -3, 0, and 3, 0. Again, the x-intercepts just come from the numerator. So you don't have to look at the denominator unless there happen to be a hole, and then you would show the cancellation. The y-intercept, go back to the original, please. Don't look at this one. Look at the original. It's easier. Plug a 0 in. This drops off, and this drops off. What's the y-intercept going to be? -9/1 or just -9? Again, take a look at this. Put these as zeros. You end up with -9 over 1 for the y-intercept, which is -9. Ashley.
Wait, so when we find that x-intercept, do we do it through the denominator?
Exactly. Because really, what are you doing? You're setting this whole thing actually equal to 0, and then you would move this up, wouldn't you? That would drop that. It would be 0 times this, which is still 0. You'd be left with 0 equals the numerator.
Wait, what if, like, if you factor the denominator
And if there was a repeating,
yeah.
then it's a whole and not an intercept. So if there had been x plus 3 here, the x plus 3s would not be counted for intercepts, and you would only use this one. Okay, whenever there's a whole, it's not an intercept. Okay? So with this information, we're going to need some other points. Let me start by graphing, get an idea. For my graph, I've got a horizontal asymptote at 1/2. I've got x and y intercepts at 3 and -3, and then down at -9. The -9 is the one that's going to throw everybody off here. So on this axis, I might want to go by, let's say, maybe I'm going by 5. On yours, you can go by like 3s probably, because you have a lot more room. Look at your graph and think logically what you would use there. So the y-intercept will be down here at -9. Again, at -9. The x-intercepts are going to be at 3 and -3. The horizontal asymptote is at 0.5, which is going to be very close to the axis here. I know that's not exaggerated well enough on mine. On yours, do it a little bit better. You have grid lines on yours. So again, this is my horizontal asymptote. Y equals 0.5. That's where that comes from. If you want to write it down. That's the horizontal asymptote. Were there any vertical asymptotes? And there was no hole. And we got our intercepts. So already it looks like this is going to be a messy problem, right? So I would definitely choose points. Well, the question becomes now, there's no vertical asymptotes to choose points around. But you do have 3 points, don't you? So maybe, yeah, go ahead. You tell me.
Can you pick like 1 and then 2 and like -1 and -2?
Well done. Okay, again, pick 1 and 2 and -1 and -2. You can even pick something as far as 5 and -5 also. I'm sorry, 4 and -4 to show what's over here. If you want to see what's going on over here, you can go as far as that. So for your table this time, you want to have, for the x values, 1, 2, -1, -2. You can really go as far as 4 and -4 if needed. We'll see if we need those in a minute, though. Again, I'm choosing 1 and 2 because, look, I have these points, and I want to know what's going on here. What is this curve going to look like? What is this curve in here going to look like? So I want to pick 1 and 2 and -1 and -2. Go into your calculator, type it into y equals, the original function, please. Did you get -2.6 repeating for the first one? And then -0.5 repeating for the second one?
Yeah.
Did the other ones come out to be the positives? Let me look actually if it's an even function or not. Let's see, -1, we'll cause that to be 2, and -4 is -8. Yeah, it should be. I think I got the same numbers to be positive over here for these two. I'm checking in my head, guys. Please check on your calculator. Okay, and then try 2. -2. Let me see your original. Here's what I'd like you guys to do for the weekend. With a few problems.